So as I promised you at the beginning of the sequence, in this sequence we will look at several new kinds of inputs. You've seen a step in various forms before. We will go through it we will go through it in more detail here. You will also see an impulse, okay, and you will also see what is called a pulse, and you will also see a ramp. So let's start with a step, okay, and I want you to be patient. We will go through a bit of theory regarding these inputs, and I promise you, towards the end of the sequence, we will tie it all back to the two motivating examples that you saw earlier, where one example had to do with the syringe and the drug delivery in a human body. And the second example had to do with this funky noise on the pins of a chip. Okay, so the first step, let's start with understanding a step input. Okay, so a unit step is simply this. So here's my time, here's 0, and let's say I have some input vi of t, and if that input has a signal, let me just change colors here to make it a little clearer, has which is 0 for some time, and then at 0 that signal goes to some DC value, and in this case it is a 1. We call that a step input. Okay, I can write that as vi of t is equal to u of t. Okay, u of t is our standard notation for a step input. So again, a unit step starts off at 0. It's at 0 for all time, and I'm sorry, it's at 0 until you get to time t equal to 0. And there it takes a jump, a step jump to 1 volt, and then it stays at that for the subsequent future. Okay, this is a step input. Okay, and we use a standard notation for a step. It is given by u of t. Now, on the other hand, if I have a step input that has a slightly greater strength, so let's say vi of t, and in this case my step input